Let's do this. Journey with me as we face, overcome, and befriend the challenges ahead. We can because we are Mathematiisin yan. I am Teacher Andrew, your soulmate. Allow me to guide you in learning the different concepts and skills in Mathematics 9. Our discussion today will center on solving word problems involving quadratic equations. Did I hear you say yay? Or you yelled yay? That sounded yikes. Nonetheless, let's get started. What about some warm-up exercises? Let us translate these verbal sentences into quadratic equations in standard form. We have sentence number 1. The length of a wooden frame is 1 foot longer than its width and its area is equal to 12 square feet. Sentence number 2. The square of a number plus 8 times the number is 20. The area of a rectangle whose length is 6 units less than twice its width is 36 square units is in sentence number 3. The sum of squares of 2 consecutive even numbers is 340 is verbal sentence number 4. Now, in sentence number 1, the length of a wooden frame is 1 foot longer than its width, and its area is equal to 12 square feet. Since the length and width are in feet and the area is in square feet, we may omit the units in representing the quantities. So the length is described in terms of its width and is specified to be 1 foot longer than its width. Hence the equation L equals W plus 1, where L is the length and W is the width. The area A of a rectangle is obtained by getting the product of its length L and width W. The area of the rectangle referred to in the problem is 12 square feet. This means that the product of the length and the width is 12. So, in terms of the width, the equation representing the area of the rectangle is W plus 1 times W equals 12. In standard form, this can be expressed as W squared plus W minus 12 equals 0. Let's record this in a table. In sentence number 2, the square of a number plus 8 times the number is 20. This is a number problem, so let's use the variable x to translate the sentence into an equation. The square of a number in symbols can be written as x squared. 8 times the number, the same number x, in symbols can be written as 8x. So, the phrase the square of a number plus 8 times the number can be translated as x squared plus 8x. Is 20 is simply equals 20. Thus, the entire verbal sentence can be translated as x squared plus 8x equals 20. In standard form, this equation is rewritten as x squared plus 8x minus 20 equals 0. Let's record this in the table. Now in sentence number 3, the area of a rectangle whose length is 6 units less than twice its width is 36 square units. The rectangle's length L is described in terms of its width W, and it is specified to be 6 units less than twice the width. Hence the equation L equals 2W minus 6. The area of the rectangle is 36 square units. Therefore, the product of the length and the width of the rectangle is 36. The area then, in terms of the width, can be represented by the equation the binomial 2W minus 6 times W equals 36. And since the binomial 2W minus 6 times W equals 2W squared minus 6W, the equation then can be expressed in standard form as 2W squared minus 6W minus 36 equals 0. But wait, there's more. We can reduce the coefficients since 2, -6, and -36 are all divisible by 2. So, let's divide both sides of the equation by 2. The resulting equation is w squared minus 3w minus 18 equals 0. Let's record this in the table. Now in sentence number 4, the sum of squares of two consecutive even numbers is 340. The numbers involved here are two consecutive even numbers. How do we represent these? We let x be the smaller even number. Therefore, the next even number after x is x plus 2. The square of x is x squared. The square of the binomial x plus 2 is written as quantity x plus 2 squared. So, the sum of their squares can be represented by the polynomial x squared plus quantity x plus 2 squared. Since the result is specified to be 340, x squared plus the quantity x plus 2 squared must be equal to 340. Hence, the equation x squared plus the quantity x plus 2 squared equals 340. And since the quantity x plus 2 squared is equal to the trinomial x squared plus 4x plus 4, we can rewrite the equation as x squared plus x squared plus 4x plus 4 equals 340 in standard form. It is written as 2x squared plus 4x minus 336 equals 0. Now, you might have noticed that the coefficients 2, 4, and negative 336 are all divisible by 2. So dividing both sides of the equation by 2 will produce the equation x squared plus 2x minus 168 equals 0. We must record this in the table. Now let's see the first verbal sentence again. We were able to translate this into the equation w squared plus w minus 12 equals 0, where the variable w represents the width of the wooden frame. Now, a question that is connected to this verbal sentence could be this: what are the dimensions of the wooden frame? This means we have to identify the length and the width of the wooden frame. So, solving the equation w squared plus w minus 12 equals 0 must give us the width. The equation can be solved by factoring. W squared plus w minus 12 is equal to the product of two binomials, namely w plus 4 and w minus 3. Hence the equation w plus 4 times the binomial w minus 3 equals 0. Equating each of these factors to 0, we must get the two values of w, which are negative 4 and 3. However, since w represents the width of the frame in feet, it can't be negative. Thus, w must be 3. The width of the wooden frame is 3 feet. Now, we determine the length of the frame. In the sentence, it is mentioned that the length is 1 foot longer than the width. In symbols, L equals w plus 1. And by substituting the obtained value of w in this equation, we must get that L is equal to 4. Hence, the length of the wooden frame is 4 feet. In the verbal sentence number 2, which we translated into the equation x squared plus 8x minus 20 equals 0, the question that could be asked is definitely, what is the number? And this we can answer by solving the quadratic equation x squared plus 8x minus 20 equals 0, since x here represents the number. And it so happens that this equation can also be solved by factoring. X squared plus 8x minus 20 is equal to the product of the binomials x plus 10 and x minus 2. Hence, we have the equation x plus 10 times the binomial x minus 2 equals 0. Equating each factor to 0, we must arrive at these values of x, negative 10 and 2. And since there are no indicated or implied restrictions for the value of x, both negative 10 and 2 are the answers to the question. Any doubt? Let's check by substituting these values of x in the equation x squared plus 8x minus 20 equals 0. So we have the square of negative 10 plus 8 times negative 10 minus 20. Is it equal to 0? Let's see. 100 minus 80 minus 20. Is it equal to 0? So we have 20 minus 20, and it is indeed equal to 0. So negative 10 is correct. We have, at this time, 2 squared plus 8 times 2 minus 20. Is the result equal to 0? Let's see. So we have 4 plus 16 minus 20. Is the result equal to 0? Next we have 20 minus 20. And this is of course equal to 0. So indeed, negative 10 and 2 satisfy the equation. This means that the square of negative 10 plus 8 times negative 10 must be equal to 20. The square of negative 10 is 100. 8 times negative 10 is negative 80. 100 plus negative 80 is 20. So, the equation is true, and hence, negative 10 is the number described in the problem. Now, the square of 2 plus 8 times 2 must also yield 20. The square of 2 is 4, and 8 times 2 is 16. 4 plus 16 is definitely equal to 20, so 2 is also the number described in the problem. Verbal sentence number 3. Just like verbal sentence number 1, it also involves area of a rectangle. It has been translated into the equation w squared minus 3w minus 18 equals 0. Now, what if the question we have to answer is this? What is the perimeter of the rectangle? The perimeter of rectangle is computed using this formula. B is equal to twice the sum of the length and the width, where B is the perimeter of the rectangle, L is its length, W is its width. So this implies we have to determine the length and the width of the rectangle. And we can do so by solving the equation w squared minus 3w minus 18 equals 0, where w represents the width. The trinomial w squared minus 3w minus 18 can be expressed as the product of the binomials w minus 6 and w plus 3, and the product should be equal to 0. And so, by equating each factor to 0, we must find that the values of w that satisfy the quadratic equation w squared minus 3w minus 18 equals 0 are 6 and negative 3. But the width can't be negative, so w must be 6. The width is 6 units. It is stated in the verbal sentence that the length is 6 less than twice the width. In symbols, L is equal to 2w minus 6. And by substituting the value of w in the equation, L must be equal to 6. The length is 6 units also. So this means that the rectangle mentioned in the situation is actually a square, since its length and width are the same. So, what is then the perimeter of this square? We just have to multiply the length or the width by 4. Hence, the perimeter is 24 units. Verbal sentence number 4, which is translated as x squared plus 2x minus 168 equals 0, could prompt us to find the numbers. Let's solve then the equation to determine what these numbers are. For 4 times in a row now, we would be solving the equation by factoring. Not that it can't be solved by other methods, but it is because factoring for me is the most convenient method to use. So, if you prefer completing the square or using the quadratic formula to solve, go ahead, live your life. So going back, the trinomial x squared plus 2x minus 168 can be expressed as the product of the binomials x plus 4 and x minus 12. And this, of course, is equal to 0. Now, if we equate each factor to 0, we must obtain the following values of x. We have negative 14 and 12. Recall that we have represented the two consecutive even numbers as x and x plus 2. This means that when x is negative 14, x plus 2 must be equal to negative 14 plus 2 or negative 12. Let's see if they satisfy the condition that the sum of the squares is 340. We have the square of negative 14 plus the square of negative 12. Is it equal to 340? 196 plus 144. Is the sum equal to 340? Yes, the sum is 340, so they are correct. Indeed, negative 14 and negative 12 are the numbers we are looking for. Now, when x is 12, x plus 2 must be equal to 12 plus 2 or 14. Do 12 and 14 also satisfy the condition? Let's see. 12 squared plus 14 squared, is it equal to 340? 144 plus 196, is it equal to 340? Yes, 340 is equal to itself, of course. And they also do. So there are two sets of answers in this problem. Negative 14, negative 12, and 12, 14. Let's have more examples of situations or word problems that can be represented by quadratic equations. The first of which is this. The height of a triangle is 4 inches, more than twice the length of the base. The area of the triangle is 35 square inches. Find the height of the triangle. Here, we need to recall the formula for the area of triangle. It is described by the equation a equals 1/2 base times height, or a equals base times height over 2, where a is of course the area of the triangle, b is the base, and h is the height. Since the base and the height are both in inches and the area is in square inches, we may not include any unit in expressing the given quantities in symbols. The area of the triangle is 35 square inches. It means that 1/2 the product of the base and the height, or when this product is divided by 2, the result is 35. The height is 4 inches, more than twice the length of the base. This can be translated into the equation h equals 2b plus 4. In terms of the base b, the area of the triangle, which is 35 square inches, can be described by this equation. Multiplying both sides of the equation by 2, the equation can be rewritten as b times the binomial 2b plus 4 equals 70. This just means that the product of the base and the height of the triangle is 70. Multiplying the quantities on the left side, the equation must be expressed as 2b squared plus 4b equals 70. Notice that 2, 4, and 70 are all divisible by 2. So, dividing both sides of the equation by 2 should produce the equation b squared plus 2b equals 35, which can be written in standard form as the equation b squared plus 2b minus 35 equals 0. And this equation can be solved also by factoring. Why? The leading coefficient, or the coefficient of b squared, is 1, the invisible 1. So we must think of two numbers whose product is negative 35, the constant term in the trinomial, and whose sum is 2, the coefficient of the variable b in the linear term. And they are positive 7, or simply 7, and negative 5. 7 times negative 5 is negative 35. 7 plus negative 5 is 2. 7 and negative 5 are the constant terms in the binomial factors of the trinomial b squared plus 2b minus 35, while the first terms are of course both b. Hence the equation b plus 7 multiplied by the binomial b minus 5 equals 0. When equated to 0, b plus 7 and b minus 5 will yield the values negative 7 and 5 respectively. B represents the base of the triangle, hence it must not be negative, so the base of the triangle is 5 inches. The height of the triangle is described by the equation h equals 2b plus 4. So by substitution, h must be equal to 2 times 5 plus 4, which is equal to 10 plus 4, and therefore h is 14. The height of the triangle is 14 inches. Problem solved! Next example. The length of the diagonal of a square measures 5 square root of 2 centimeters. What is the length of each side of the square? Recall that the square is a quadrilateral whose 4 sides are equal and whose 4 angles are 90-degree or right angles. A diagonal is a segment that connects 2 non-consecutive vertices of a polygon. In the problem, the diagonal of the square measures 5 square root of 2 centimeters, and we are to find the length of each side of the square. All sides of the square have the same length, so we can represent all of them using one variable, say s, which is also in centimeters. Since we are only given information about the diagonal of the square, nothing about its perimeter or area, we will solve the problem by treating it as a problem involving a right triangle. In the figure, we see that the diagonal divides the square into 2 congruent right triangles. Let's focus on just one. The diagonal of the square is the longest side of the right triangle, which is called the hypotenuse, and is 5 square root of 2 centimeters long. The 2 sides of the square are the shorter sides of the right triangle, which are called the legs, and are both represented by the variable s. Pythagorean theorem describes the relationship of the sides in a right triangle and is given by the equation a squared plus b squared equals c squared, where a and b represent the lengths of the legs, while c stands for the length of the hypotenuse. In the problem, the legs are both represented by the variable s since they are equal in length. Hence, a and b will be substituted by s. c will be replaced by 5 square root of 2. So we have the equation s squared plus s squared equals the square of 5 square root of 2. S squared plus s squared equals 2s squared, while the square of 5 square root of 2 must be equal to the product of 5 squared and the square of square root of 2. And this can be written as 25 times 2 and hence equals 50. Thus, the equation can be written as 2s squared equals 50, which is of the form ax squared equals k. We divide both sides of the equation by 2. The resulting equation is x squared equals 25. Then, we can now extract the square root of both sides. We should get s equals positive or negative 5. The variable s represents the length of each side of the square. Thus, it has to be positive, and so s must be equal to 5. The side length of the square is 5 centimeters. Problem solved! Kagamath, ready your pen and paper. It's Math the Moment! Problem number 1. A wire that is 32 centimeters long is cut into 2 pieces, and each piece is bent to form a square. The total area enclosed by the 2 squares is 34 square centimeters. Find the length of each piece of wire. For 45 seconds, go! Time is up! Since it is not indicated that the wire is cut into 2 pieces of equal length, we assume that one piece is longer than the other. So we let x be the length in centimeters of the shorter piece of wire, and the other piece must be 32 minus x centimeters long. We may not include the unit centimeters. Both pieces are bent to form a square. Hence, the length of each piece of wire is the same as the perimeter of the square it is bent into. So, getting 1/4 of the length of the piece of wire or dividing this length by 4, we must get the side length of the square the wire is bent into. Area of square is obtained by multiplying its side length by itself, or simply squaring the side length. For the shorter piece, the area of the square it is bent into must be equal to 1/16 of x squared or x squared over 16. For the longer piece, the area of the square it is bent into must be equal to 1/16 of the trinomial 1024 minus 64x plus x squared, or 1024 minus 64x plus x squared all over 16. Since the sum of the areas enclosed by the two squares is 34 square centimeters, we write this equation. We may multiply both sides of the equation by 16, and the resulting equation is x squared plus 1024 minus 64x plus x squared equals 544. Written in standard form, the equation must be expressed as 2x squared minus 64x plus 480 equals 0, and can be reduced as x squared minus 32x plus 240 equals 0 when both sides are divided by 2. And it can also be solved by factoring. X squared minus 32x plus 240 is equal to the product of the binomials x minus 12 and x minus 20. Hence the equation x minus 12 times the binomial x minus 20 equals 0. Equating each factor to 0, we can arrive at these values of x, 12 and 20. We let x be the length of the shorter piece, hence x must be 12. The shorter piece is 12 centimeters, while that of the longer piece must be obtained by subtracting 12 centimeters from 32 centimeters, in which the result is 20 centimeters, since its length is represented by the expression 32 minus x. Problem solved! Problem number 2. What must be the length of the hypotenuse of a right triangle if the legs are 6 units and square root of 13 units long? For 30 seconds, let's do this! Time is up. Drawing the figure will help us visualize the problem better. The hypotenuse C is unknown. Let the leg A be 6 units long, while leg B is square root of 13 units long. Applying the Pythagorean theorem, we can arrive at the equation 6 squared plus the square of square root of 13 equals C squared. This means that C squared is equal to 36 plus 13, and hence C squared must be equal to 49. Extracting the square root of both sides, we must get that C is positive or negative 7. But C represents the length of the hypotenuse and therefore should not be negative. So C is equal to 7. The hypotenuse is 7 units long. Problem solved! Problem number 3. A 12 cm by 16 cm picture is mounted with border of uniform width on a rectangular frame. If the total area of the border is 288 square centimeters, what is the length of the frame? For 30 seconds, go! Time is up. Let x be the width in centimeters of the border of the frame. Hence, the width of the frame is equal to x plus 12 plus x, or 2x plus 12, which is equal to 2 times the binomial x plus 6. While the length in centimeters is equal to x plus 16 plus x, or equals 2x plus 16, and in factored form, 2 times the binomial x plus 8. Now, we must realize that the total area of the border plus the area of the picture is equal to the area of the rectangular frame. The area of the border, as stated in the problem, is 288 square centimeters. The area of the picture, as described by its dimensions, 12 centimeter by 16 centimeters, is 192 square centimeters. Hence, the area of the frame is equal to 288 square centimeters plus 192 square centimeters, which is 480 square centimeters. Since the length of the frame is given by the binomial x plus 8 times 2, while the width is expressed as 2 times the binomial x plus 6, this means that 2 times the binomial x plus 8 times 2 times the binomial x plus 6 is equal to 480. This can be expressed as 4 times the product of the binomials x plus 8 and x plus 6, which is equal to 480. Now, if we divide both sides by 4, it will result into the equation x plus 8 times the binomial x plus 6 equals 120. In standard form, it should be written as x squared plus 14x minus 72 equals 0. The trinomial x squared plus 14x minus 72 is equal to the product of the binomials x plus 18 and x minus 4. Hence, the equation x plus 18 times the binomial x minus 4 equals 0. Equating each factor to 0, the values of x are negative 18 and 4. X is the width in centimeters of the border of the frame. Hence, x must be 4. The width of the border is 4 centimeters. The length that is represented by the expression 2 times the binomial x plus 8 must be equal to 2 times the sum of 4 and 8. And this must be equal to 2 times 12, which is equal to 24. Thus, the length is 24 centimeters. Problem solved! And it has been another learning-packed episode, Kagamath. Before we go off air, be reminded that you don't have to be a genius for you to love math. We are mathematician yan. We all are. See you in our next journey. Bye!